my first real car project was to take a 1937 Lincoln Zephyr, which I'd gotten two of when I was 15. I acquired two 37 Lincoln Zephyr coupes. One was just a body and chassis, but no engine, no internals, and the other was a body and a portion of a chassis, not all the suspension on it, and again, no engine. So I got these two things, and like I was 15, and I had to figure out what I wanted to do with these things, right? So I decided right away that I wanted to seriously modify one of these cars. I decided that the car was too high, and so I wanted to make it lower. And one of the ways you might be able to make a car lower in those days was to take a section of the bodywork out of the middle of the car.
And regrafting those back together, was there metal shaping involved?
There was some metal shaping involved. There was welding involved. There was figuring out how to make the cuts. So I decided what I wanted to do, but I wasn't able to do it because I hadn't learned how to weld yet, and I'd never done that sort of body work before on any car, much less my own. So it was quite a challenge to take on.
That led you, obviously, that was your first project, learning curve extremely steep at the beginning, learning how to do for the first time basically all the things you needed to do to accomplish that task.
I did manage to learn how to weld when I was 15, so I managed to get the top half of my car hooked onto the bottom half, and then I was liking sports cars at that time, so out of sheet steel I grafted new pieces of steel onto the original car, and I decided to get an Oldsmobile engine at the time for my car, and then I started modifying the engine because in its original form it obviously didn't make enough horsepower ever. So the car was really an excellent learning device for how to build an engine, because I ended up taking the engine apart and building it into a much higher horsepower engine than before. And I'd gotten the engine to the point where the car was quicker, at least in a straight line, than a fuel injection Corvette of the era. That's 1957. So I could beat Corvettes on the street and at the drag strip and run 102 miles an hour in the quarter with this car, but it certainly wasn't a sports car. And I'd followed the sports car business and gone to some sports car races, but I hadn't really thought in terms of what I was going to do with car construction or anything in my future with cars until I got a ride in Austin Healey 6. And that totally changed my vehicular technical direction. And at about the same time, a chassis for a 1935 Maserati Formula One car was floating around Seattle. It had been floating around Seattle and for sale for some time, and I became aware of it. And since I'd been working and saving some money, working at Boeing's and saving a little bit of money, I had the $600, which was required to purchase this lovely Maserati Formula One car with no motor and no bodywork. But it gave me the chassis, wheels, a transaxle, no motor, and so I got that at my house, and I decided that my next project was to design and build a sports car, which involved building a frame for the car.
If I remember the entirety of the story correctly, everybody nowadays talks about, in this world, not to get into the details, talks about 4130 tubing and tube notching and CNC this and CNC that. And when you were telling me about some of your first tube chassis you'd made, always triangulated properly using 028 or 035 rolled tubing, gas welded, and you notched it with tin snips. Is one of the coolest things I tell people about how it can be done. So obviously you started first with your Zephyr, your first sports car, but the thing that's funny about this is the number of cars that came after this is so extraordinary. And I don't know, if I look through the timeline, there has to be at least 15 to 20 other race cars down the line. Nissan GTP, championship winning Nissan GTP car you designed, the Can-Am Shadows, a close
The first one.
the first Can-Am Shadow. But yeah, I think you've always been regarded as the outside the box thinker and developer, because you're always looking at what the goal is, what the outcome is. You're not looking to what other people have done necessarily to determine what you're going to build.
If you're doing a race car, there's one other thing it's got to be able to do. As far as I'm concerned, it's got to be able to win. And that's another constraint in a way. It's got to be able to win, which implies it's got to be able to finish.
So what you were just talking about makes me laugh, because I feel like you're always trying to dig deep to find the real cause of a problem, whatever the problem will be. And there's no limit to what you will personally do to figure out what that problem is. And there's a picture of you on the internet riding on top of an Indy car with the driver going around the track to try to figure out what a problem was.
Yeah.
And I've seen you personally, fish your way into a rotating driveline assembly with a car up on jack stands in sixth gear to troubleshoot a problem. And you had absolutely no fear. You know what every mechanical system was doing, and you're trying to troubleshoot an issue. What was the IndyCar story?
Oh, the IndyCar story was, yeah, that's a good story. In 1983, I had the job of designing a new Indy car for Al Unser Jr. to drive. So we were testing the car one day with a number of other teams were there, and the car, every time Al Jr. drove the car on the track, it wanted to pull to the right, okay? The car had a problem in the steering, and it defied me finding it. I couldn't find anything wrong with the car. We spent a lot of time double checking everything. Every time he drove it on the track, it did something wrong. So I decided that maybe, that if I sat on top of the car, basically just behind the roll bar, sitting on part of the airbox and holding onto the roll bar for dear life, and I wanted him to drive, see if, he'd drive around the track, not at race speed, but I wanted to see if I could see something.
Did you find the issue?
So anyway, the bottom line is I couldn't see anything funny, nothing. So we got done running, and it developed that the different teams there, we don't all talk to each other all the time. But when people started comparing notes, it turned out we weren't the only ones with that problem there. It was a tire problem. It wasn't a chassis problem. Oval track tires are designed there is a different tire at every position of the car. And for some reason, there was some kind of a internal carcass problem with the tire, the way the plies were done or something. I don't know. But we weren't the only car that was having that identical problem that day. We just thought we were. We touched a little bit on several of the earlier cars that I've designed over the years.
But what do you think is one of the most iconic?
Okay, iconic is an interesting word. Probably if that means the fondest in some way memory from a technical point of view, it would be the Mark I Shadow, which was absolutely not a successful winning car, but it was technically the most interesting car I ever designed. Probably the most iconic car from the standpoint of winning goes, or cars, would be the Nissan GTP cars, the chassis of those cars. I was the chief designer of the 88 Nissan GTP car and the 90 GTP car, and they both won 2 championships. So those cars, they provide me with a great memory too.
And what was kind of weight of the car, horsepower, and downforce?
Weight, about 2,200 pounds. Horsepower, about 800 to 850. Top speed, not terribly exciting because we had a lot of downforce on those cars, and downforce implies there's a penalty that you get for downforce, which helps cars to adhere to the ground, and the penalty is drag. And drag equals horsepower consumed. And so we consumed a lot of horsepower pushing the car into the ground to get it around the turns fast. But
what kind of downforce?
For instance, so the downforce of our cars, the downforce figures that you could get, which wouldn't necessarily equate with how you ran the car on the track because of trying to get the car balanced properly, but they made over 10,000 pounds of downforce at 200 miles an hour, significantly more than 10,000 pounds.
And what do you think the top speed of those? You said not.
Top speed at Daytona, 185 miles an hour, for instance. Other cars were 15 miles an hour faster than we were, but much slower in the corners.
No active aero allowed, no adjustment of wings.
No adjustable aerodynamic devices on any of the modern sports cars. Nothing adjustable. That all ended in 1970. 1970, a lot of people were racing cars with adjustable wings in the 60s. And if you've got an adjustable wing angle and something about the adjustment system fails, you can crash. And a lot of people died in the 60s from crashed vehicles that had aerodynamic parts that changed position.
That you lived through that era of motorsport, which was, let's call it 1965 through 1975, which I feel like the learning curve and technology curve for aerodynamics in that realm of motorsport was insane. Must have been, right? I mean, you look at a Formula car from 1965, basically no aerodynamics, and by 1970, all the cars had wings. And I remember I don't remember personally, but I've seen the history of the first few cars in Formula One or the first few races where they had those large wings up behind the roll hoop. Wings were breaking off, and it was.
Well, there are a lot of early cars with wings that were mounted to struts that came down and mounted onto the suspension pieces.
Which ideally is best case scenario.
And that was really good, except those had a lot of mechanical problems because of the just sheer amount of vibration. And so wings on the very early cars were done that way quite often. That gave way to mounting the wings on the bodywork, which was much safer. But in the beginning, wings on the bodywork of cars were fixed wings in position. And then somebody figured out that if they made the wing adjustable in angle, you could do wonders for top speed on a straight line down the straightaway, and then adjust the wing angle to give you good downforce in a corner. And that was great, but those wings also, mechanisms failed, and people failed as a result of them.
What blows my mind is that attaching struts to the suspension uprights from a wing is the most ideal scenario to not affect how the car is sprung as a function of downforce. And just because the wings or links failed makes me feel like they could have worked at mechanical robustness rather than moving the wing to the sprung to the bodywork. I'm surprised in history people never went back to strut mounted wings.
Well, that's interesting. They didn't. And mounting the wings on bodies became, they were on every race car was done that way. And they could have gone back, but I think the impetus to do that never was really there. You could do it, but mounting the wings on the bodies gave you the downforce, right? Could. It did introduce issues, but the way history works is the way it worked.
Maybe we'd do it again. And you could even make that wing, variable pitch.
You could for your project. Projects.
TBD.
Yeah.
Thank you so much for coming to visit and chat through cars and kind of mentoring me for all these years and being a huge part of my life.